Thanks for joining me again today. We're going to get a little bit further into ionic compounds. Specifically, what we're going to be doing is looking at ionic formulas, and this is going to help us understand how to be able to start writing and start naming some of these simple ionic compounds that we're going to get into once we start putting positives and negatives together. And let's hop right into this. So real quick though, next slide, just to hit our new learning contents and objectives. Here's kind of what we're doing. By the time you finish this, if it's good for you to come back and look at this, would be great, but we really are trying to accomplish what it says here. Write and name the proper chemical formula for an ionic compound. And specifically what we're doing is looking for elements that are in groups 1, 2, and 13. These are kind of our first three groups of metals, not counting the transition metals. And then nonmetals are our last three groups that are not the noble gases. So we're going to try to be able to start looking at how to put those together. Some vocabulary we will get into: formula, monoatomic, compound, and a subscript. So saw the slide before possibly. And as a reminder, just remember all elements except the noble gases gain and lose electrons. So the whole goal here is that things they want their electrons to become like a noble gas. None of the other ones are like a noble gas. Their outside shell is not complete. They have one electron or two, all the way up to 7 valence electrons. Again, that's our outside shell electrons. The noble gases have theirs completely full, and so they tend to be stable. So the idea is the other elements are trying to do that, and in order to do so, they may lose electrons. Metals tend to do this. Again, the L on there to help us remember the left side of the periodic table loses electrons, and if we forget, we can use our hand to make an L shape for that. Nonmetals, typically on the right-hand side, tend to gain their electrons to become more like noble gases. So that's just a quick review. All right, when we have an ionic bond, the bond is kind of this invisible force that's holding two things together. Specifically, when we talk about ionic bonds, just to reuse some of our vocabulary, what we're looking at here specifically are cations, which are the positive ones, and the anions, which are the negative ones. This was in a previous video where we looked at cats being positive and onions, which is almost what the word anion looks like, being negative, kind of causing us to be able to cry. So when we have positives and negatives, they attract one another. They have this invisible bond that holds them together. And when that occurs, they turn into a compound, which is a substance unlike any of the ones that make it up. So in the picture we have on the right, we've got sodium and chlorine. Sodium is a metal, chlorine is a nonmetal. When they come together, they form sodium chloride, which is what we put on our food as table salt. So compound is when we have two or more elements chemically bonded or chemically combined together. Again, in that picture, the resulting compound in this little illustration would be called sodium chloride, NaCl. Now, in some cases, the number of atoms that we have in a compound is pretty simple and pretty straightforward. Sometimes it gets a little bit more complicated, but in general, the number of atoms, it kind of depends on the oxidation number of the particular atom. So as a reminder, oxidation number, that's the charge it would get if it gains or loses. So you can see in this illustration over here, sodium has one electron that it's going to get rid of. Sodium's oxidation number is +1. Again, it's in the first column of the periodic table. Chlorine has 7 valence electrons, which is why it's in group number 17, meaning it will take 1 electron. And so if we know the valence the oxidation number of each one of these, +1 and -1, then we can kind of predict that these two things would come together, because if we combine those, then they basically cancel each other out, or they neutralize one another, and the attraction is complete. So again, our goal with an ionic bond is we want to cancel out all of these charges. So in the illustration right there, that tends to be pretty simple. And what we end up doing is writing a formula. And I like to think of the formula as being kind of the recipe for a compound. So if we say sodium chloride, that doesn't tell us how many sodiums and it doesn't tell us how many chlorines. The formula for sodium chloride, which would be NaCl, does tell us the number. So some examples of properly written formulas: NaCl, MgO, MgCl2, Li2S. These have to be in the perfect right ratio. So in other words, giving some non-examples, and these look like they should be kind of the same thing, but they're wrong. NaCl, when sodium and chlorine get together, this is always the formula. There's always one sodium. And notice when we don't have a number down here, we're going to infer that there's a 1. So there's one sodium for one chlorine. There's never two sodiums for a chlorine. there's always one magnesium for one oxygen. There's never two magnesiums for one oxygen. So we have rules that we need to follow in order to get a proper formula, and that's what we're going to hit here in just a second. So here's how we go about writing the formula. So this is definitely something we want to make sure that you're taking notes on. Our our rules here is we need to write the symbol and we need to write the oxidation number, and you might have to use your periodic table to be able to do that. If I'm doing sodium and sulfur and I wanted to correctly write their formula, again, step one, write the symbol for each and write the oxidation number for each. Sodium is in group 1, sulfur is in group 16 beneath oxygen. So we write the symbol, we write the oxidation number. That's our step one. Always, always, always. If you do these steps, it's really hard to mess up. We always put the metal first. Again, looking at the periodic table, the metal is always on the left and it always comes first. And then our next step is we do this thing called a crisscross. And if we crisscross our numbers to the bottom, we're going to put them where what we call a subscript. We talked about superscripts at the top. We've got subscripts at the bottom. So the idea is that this 2 is going to end up going down here, and the 1 is going to end up over here. And this kind of tells me the ratio. Now notice what I didn't bring along for this. This is just kind of a shortcut. I'm not literally moving the oxidation numbers. It's just a shortcut for us to be able to do it. I don't bring the plus or the minus with us. This tells me what the ratio properly is. So in other words, for these to cancel out, I would need 2 sodiums and I would need 1 sulfur. And so when I finish this up, my properly written formula would be Na2 and then just a regular S. I don't continue to put the 1 down here. So again, a couple of things we don't do with the crisscross. We don't ring the pluses and minuses with us, and we never end up writing a 1 when we're down here. Okay. The last part is remember that this is basically a ratio. So it takes 2 sodiums to balance out a sulfur. And hopefully this kind of makes sense. In other words, it takes 2 plus 1s to cancel out a minus 2. If we put all of those together, what do we get? All of that would equal out to 0. So properly written formula is going to give us everything canceled out. All right. So just as an example, magnesium and oxygen is another one. I've got some pictures here. This is what magnesium and oxygen looks like. So going back through our rules, rule number 1, let's write down symbol. The metal comes first, the non-metal comes second. We would write their oxidation number. Magnesium is in group 2. Oxygen is in group 16. Again, you would use your periodic table to help you with this. If we do crisscross method on this one, the 2 is going to come here, and the 2 is going to come here. And you might be very tempted to finish up your answer by being like this, but our formula again needs to be a ratio. And so if we have a ratio of 2 to 2, we can basically reduce that down, right? 2 to 2 is the same thing as 1 to 1. And so our finished formula would just be MgO for magnesium oxide. Again, the reason why is I'd only need 1 of these to balance out 1 of those. So we always want to get it into its smallest ratio, or the simplest form, if you want to think of it that way. All right. Again, if we did another one, barium and bromine, real fast. Barium's the metal. Bromine's the gas. All right. If I look on the periodic table, staring one at the back of the room, barium is in group 2. So that's a +2 charge. Bromine is in group 17. So that's a -1 charge. Do a little crisscross action here. So the 1 ends up going over here. The 2 ends up going over here. And then my final formula, again, it's a 1 to 2 ratio. My pen doesn't like to work the whole time. Again, I don't write the 1 because it's assumed to be there, but I do write the 2. So the formula for barium and bromine would end up looking like this, BaBr2, and would be called barium bromide. All right, so finishing this pretty quickly, we can also name the ionic compounds. This is really simple. We name the metal first. We then name the non-metal, but we have to make a little change here. We have to change the ending to IDE. So the example in the picture I've got over here, this will be called barium bromide, which is the one we just worked out. So the nonmetals, we have to change things. Sulfur turns into sulfide, iodine turns into iodide, for example. Chlorine turns into fluoride. Those are pretty easy. There's several that get a little bit confusing. Oxygen turns into, it's not oxygenide, it's oxide. It's not nitrogenide, it's nitride, so that's for nitrogen. And it's not phosphoruside or phosphoride. Phosphorus turns into phosphide, and those are just kind of some exceptions to the just dropping the ending that we have to memorize. So in summary, when we do ionic compounds, we're looking at putting a metal and a non-metal together. Are able to write formulas, which is going to show the ratio of one to the other. And then when we end up naming them, pretty simple, we're going to be able to name the metal and name the non-metal with an IDE form. If you got some practice to do after this, good luck with it. Thanks for joining me. See you later.